Swayam Prabha. Digital India. Educated India.
Lesson 2.5 Highway Capacity and Level of Service. After completing this lesson, the student will be able to understand the concept of capacity and level of service for highway facilities, identify the factors affecting capacity and level of service. Student will be able to estimate the capacity and service volumes for different highway facilities. Let us try to understand the concept of capacity. First, a formal definition as given by Highway Capacity Manual 2000. Capacity is defined as maximum hourly rate at which persons or vehicles can be expected to traverse a point or uniform section of a lane or roadway during a given time period under prevailing roadway traffic and control conditions. There are several interesting and important aspects of this capacity concepts as given in the definition. So, I would like to give emphasis on those aspects. Carefully observe that capacity is defined as maximum hourly rate. It is maximum hourly rate, not the volume. The difference in traffic volume and rate is already known to you. So, it is the maximum hourly rate. Usually peak 15 minutes is taken and expressed as equivalent maximum hourly rate. So, that rate capacity refers to maximum hourly rate. It also is defined or expressed in terms of persons or persons or vehicles. So, it may be in terms of vehicle capacity, it may be in terms of passenger capacity. Passenger capacity concept is critical when particularly if transit is considered or high occupancy vehicle lanes are considered. There in those contexts, person capacity is more meaningful and contextual. Observe that capacity is also defined for prevailing roadway traffic and control conditions. What is prevailing roadway traffic and control condition? If you pick up a roadway segment and try to understand the capacity, it is under the given roadway traffic and control conditions. That means, capacity is linked or defined with respect to a given or prevailing roadway traffic and control condition. You change the roadway condition, you change the traffic condition, you change the control condition, capacity is going to be influenced. You will get a different capacity value. Also, capacity is defined for a point or uniform section. This is again consistent with prevailing condition. A point or uniform section means uniform in terms of roadway, traffic and control condition. So, along the length of a road at different segments or at different points, if the prevailing roadway, traffic and control conditions vary, obviously the capacity also will change. So, capacity is again defined with respect to a point or uniform section. Also, capacity refers to maximum flow that can reasonably be expected, very, very important this part, can reasonably be expected to traverse a section. That means, we are indicating that capacity varies in both time and space. Remember that we have included, it is included in the definition, can reasonably be expected. That means, it is not the single highest flow level ever expected to occur for a facility. It is not the single highest flow level ever expected to occur. Rather, we are referring to maximum flow rate, a value that can be reasonably achieved repeatedly, not once in a while, once in lifetime you achieve what the highest flow and that try to refer as capacity. No, that is not the capacity. Capacity is the maximum flow rate that can reasonably be achieved again and again for a given facilities. So, capacity is not the single highest flow level. Therefore, isolated observations more than capacity is not a contradiction, but an expected condition. If you measure traffic flow and express it in terms of flow rate, sometimes you may get even a value which is higher than the prescribed capacity of that facilities under prevailing roadway, traffic and control condition. It is not a contradiction to capacity definition. You should not think that since you have observed a flow more than the prescribed capacity, there is something wrong. It is not a contradiction, but an expected condition. With this concept of capacity, let us now try to understand the concept of level of service. Again, first the formal definition as given by Highway Capacity Manual 2000. It is a quality measure describing operational conditions within a traffic stream, generally in terms of such service measures as speed and travel time, freedom to maneuver and traffic interruptions and comfort and convenience. So, it is a quality measures which is describing operational conditions within a traffic stream in terms of service measures such as speed and travel time, freedom to maneuver, traffic interruptions, comfort and convenience. Now, 6 levels of service are recognized, designated from A to F. So, in short we say LOS A, LOS B, like that, with LOS representing the best operating condition. Now, maximum freedom to maneuver is possible when it is free flow condition. So, obviously, level of service A is defined for free flow condition and LOS F is defined for worst possible operating condition, that is the forced flow condition or breakdown flow condition. For each facility type, one or more stated performance measure serves as primary determinant of level of service. We have understood but the concept of level of service, but how to say that a given facility is operating under which level of service, we need some quantitative basis for defining level of service. The quantitative basis is called as measure of effectiveness, in short MOE, measure of effectiveness for that facility. Now, each level of service represents a range of operating conditions and drivers' perception of these conditions. Whatever may be the measure of effectiveness, it is within a prescribed range, we call it a particular level of service. It is in another range, we call it is another level of service. So, each level of service, it represents a range of operating conditions and the driver's perception of those conditions. So, level of service are essentially step functions. Under certain, it is A, then B, then C, like that. So, these are essentially step functions, each representing a range of operating conditions. Let us have a look at some of the measure of effectiveness for defined LOS, for uninterrupted flow facilities and also for interrupted flow facilities. For uninterrupted flow facilities, let us say freeways, measure of effectiveness is density. For different facilities, different measure of effectiveness are prescribed. For freeways, it is density, which is normally expressed as passenger car per lane. How many passenger cars per lane per kilometer? Multi-lane highways, again density, number of vehicles per lane per kilometer. For two-lane highways, two measure of effectiveness are used. One is average travel speed and the other is percentage time spent following, because particularly for two-lane highways, overtaking or passing opportunities is a crucial aspect. So, often it may happen that a heavy vehicle is going and all other vehicles are forced to follow that vehicle. So, what is the percentage of time spent for following, that is also a consideration. So, it is based on average travel speed and percentage time spent following. For interrupted flow facilities, signalized intersection and unsignalized intersection, both case it is control delay, how many seconds delay per vehicle. We will discuss more about the control delay, what is control delay. For urban streets, it is average travel speed. So, it is maybe kilometer per hour. These are general ideas about MOEs for different roadway facilities, both uninterrupted and interrupted. It is worthwhile to mention that two similar facilities with same level of service may differ more than two with different level of service, depending upon where they are in the defined range. This, let me try to explain this part. Suppose we are defining LOS in a range. Suppose this is one range, let us call maybe it is LOS B, and then this is the range for LOS C. So, let us consider two operating conditions here, both are defined by level of service, described by level of service C. So, in MOE values the difference may be much higher, but both of them under level of service C, whereas let us now consider another operating condition, say here the difference between these 2 points are very less in terms of MOE values, but one is left side of the boundary and another is maybe right side of the boundary. So, one case it is level of service B, another case level of service C. So, whatever measure of effectiveness you have considered, you may find that there are two operating range operating conditions within the same level of service, but MOE values are much different or as compared to another two operating conditions where you are actually telling them two different levels of service, but difference in MOE is much lesser. Coming to the concept of service flow rates, this concept is again related to level of service. Service flow rates generally represent the maximum flow rate that can be accommodated while maintaining a level of service. That means, for a given level of service range, what is the maximum flow that can be accommodated? That means, maximum flow that can be accommodated within that given level of service. Obviously, it goes to the boundary condition, goes to the boundary. So, service flow rates may be defined for levels of service A to E, but service flow rates are not defined for LOS F. The reason is obvious, because LOS F represents unstable flow operation or forced flow operation. So, you cannot really define the maximum service volumes with respect to LOS F. This is a representation of level of service in the form of indicative volume flow condition. You are familiar with this shape of the curve. It is a speed volume curve when the volume is practically insignificant, maybe in the lean hours, early morning or midnight. You may find less number of vehicles which are travelling at a very high speed, and then as vehicle volume or flow increases, there is a drop in speed. It may not be so steep really, but this is a conceptual depiction. So, you can define this whole operating range into different levels of service. Maybe this is level of service A, this operating zone B, this is C, this is D, E maximum service volume with respect to E, this is nothing but the capacity, and then this whole portion, this shaded portion is actually unstable flow. So, you can understand clearly why we do not define service volume with respect to level of service F. This is a conceptual representation of the level of service in speed volume domain. Now, coming to the factors affecting capacity and level of service, there are several factors. We will classify them under some broad categories. First, roadway factors. Roadway factors include lane width. According to highway capacity manual, a lane width of 3.6 meter is considered ideal. So, if the lane width is varying, is lesser than 3.6 meter, obviously the capacity will be lesser or the capacity will decrease. Similarly, lateral clearance such as retaining wall obstructions such as retaining walls, abutments, signposts, light posts, parked cars, etc., located closer than 1.8 meter from the edge of traffic lane. If these obstructions are located closer than 1.8 meter from the edge of traffic lane, that means lateral clearance is less than 1.8 meter, then that will, those obstructions will influence capacity, and no doubt capacity will be reduced. Next roadway factor is width of shoulder. Narrow shoulders reduce capacity, effective width of traffic lanes as the vehicle travel towards the center of the pavement. Therefore, narrow shoulder also affects capacity. Grade also adversely affect the speed of vehicle, particularly if you have substantial proportions of commercial vehicles or heavy vehicles. So, therefore, on grades, presence of heavy vehicles together may really influence the capacity to a large extent. Presence of intersections also do influence capacity, because intersections restrict free flow of traffic and thus adversely affect the capacity. Alignment also influence the capacity, particularly side distance. If adequate side distance is not available, then that will affect the safety as well as the capacity on the road. Surface condition also will affect capacity. If the surface condition, road surface condition is very poor, obviously the speed will be reduced, because vehicles cannot travel at higher speed, and therefore, you will find that capacity may get influenced or capacity may become lesser on roads with bad surface conditions. So, these are all factors, namely roadway factors, which affect the capacity. There are traffic factors, a set of factors which again affect capacity, particularly the percentage of commercial vehicle. This is very important. More the commercial vehicle percentage, the capacity is going to be affected. Larger commercial vehicles like trucks and buses influence the traffic stream in two different ways. First, they occupy more space than passenger cars, because they are bigger vehicles, so obviously they will occupy more space, but they are distinctly different in terms of acceleration deceleration capability. So, that is another major aspect why percentage of commercial vehicles affect capacity. So, they have poor operating capabilities than passenger car, particularly with respect to acceleration deceleration and ability to maintain speed in upgrade conditions. So, that is why traffic factors are also important. Directional distributions also play an important role, particularly for two-lane highway facilities, because both upstream and downstream traffic, they use the same road. It is a two-lane road, it is not divided road. So, therefore, the capacity is also influenced by the directional distribution or the directional split. Let us look at some of the points, salient points as mentioned in Indian Roads Congress guideline. As per IRC, it is not advisable to design the width of road for a traffic volume equal to its capacity. Obviously, there is a reason for that, because if a facility is designed for level of service E, no doubt the traffic volume can be accommodated, but with a poorer performance. Maybe the speed will reduce, the density speed will reduce, the density will become very high, freedom to maneuver will come down drastically. So, therefore, the quality of traffic operation will not be up to the desired level. So, therefore, facility is not designed with respect to the service volume with respect to level of service E or capacity. IRC recommends that under normal conditions, level of service B may be adopted for rural roads and facilities may be designed for level of service C for urban roads. That is what IRC recommends. Accordingly, instead of capacity, we can take level of service B or the corresponding service volumes while designing rural roads and urban roads. In rural highways, instead of hourly volume, daily traffic volume is adopted for design. So, IRC suggests or in IRC manual guideline, daily volume is adopted for design purpose. Obviously, daily hourly volume is derived assuming 8 to 10% of the daily traffic as peak hour traffic. So, there is a relation, and 30th highest hourly volume is also considered, but IRC code says that capacity in terms of daily volume, not in terms of hourly volume. Design service volume considered for design purpose is expected volume at the end of design life. That means, when we are going for road infrastructure planning, we plan the facility or we consider economic life period. Say normally for a road project it is 20 years. So, the traffic volume what we are taking and comparing it with the maximum level of service or maximum service volume with respect to level of service B, say for rural highways. That traffic volume is not the present traffic volume, but the projected traffic volume at the end of design life. So, at the end of design life, what is going to be the traffic volume? We take that and accordingly we decide what will be the lane requirement or capacity requirement. So, obviously, this can be computed, the projected traffic or the forecasted traffic, by projecting the present volume at an appropriate traffic growth rate. So, we take the present volume, we estimate the ADT, average daily traffic, we take into consideration the seasonal variation. So, we calculate estimate ADT, annual average daily traffic, use suitable growth factors to project this base year or the current year annual average daily traffic to forecasted traffic in the at the end of design period. So, traffic growth rate should be established. For doing that, after carefully studying the past trends and potential for future growth of traffic. So, normally growth rates, there are different methods for estimating the traffic growth rate. We are not going into details, but the basic steps are estimate base year traffic, use suitable growth factor to forecast the base year traffic. Now, those forecast or the growth factors are estimated looking at the past traffic trends and also looking at the future strategy of development in the influence area of the project. This is an example of design service volumes as given in IRC manual. They consider different three types of terrain: plain, rolling and hilly. Again they divide it based on the curvature, low or high curvature in each terrain condition. Curvature is defined based on degree per kilometer deviation, horizontal deviation or the curvature in terms of degree per kilometer. So, low and high accordingly they are defined, and for each type of terrain with each type of curvature either low or high, the design service volumes are given in terms of passenger car unit per day. So, so many cars per day. So, it is daily volume that is given. Capacity of two-lane road can be increased about 15% by providing paved and surface shoulder of at least 1.5 meter width on either side. This is again Indian Roads Congress provision. So, if we provide paved and surface shoulders of at least 1.5 meter width on either side, then the capacity or the service volume values may be increased by 15%. Where the shoulder width or carriageway width on a two-lane road is restricted, there will be certain reduction in capacity. So, IRC guidelines also give some table to calculate the factors like what is the usable shoulder and then what is the lane width. Accordingly, these factors may be obtained or may be taken from the table given in IRC code, and accordingly this much reduction may be done in the capacity. Now, coming to highway capacity manual approach, the analytical methods in HCM attempt to predict the maximum flow rate for various facilities at each level of service except LOS F, as already stated, because LOS F represents unstable flow. Each facilities has 5 service flow rates, LOS A to LOS B, representing one for each level of service, that is A to E. Service flow rates are discrete values, whereas level of service represents a range of condition, because level of service represents a range of condition, but service flow rates are discrete values. What is the maximum traffic flow rate that is possible maintaining a given level of service. So, these are essentially boundary values. So, obviously, service flow rates are discrete values, but level of service represents a range of conditions. Service flow rates are the maximums for each level of service. They effectively defining flow boundaries between level of service. So, obviously, I indicated that one, that these are the different level of service descriptions maybe. So, what is the maximum flow rate with respect to level of service? This is this one, again here, here. So, essentially these are flow rates, maximum flow rates for each level of service. Therefore, they effectively define the flow boundaries between level of service. Now, this base condition, understanding about the base condition is important, because procedures in HCM provide formula, sometimes may be simple tabular or graphical representations for a set of specified standard conditions which must be adjusted to account for prevailing conditions. So, there are prevailing conditions which are not ideal or which are not the base conditions. So, HCM defines certain base conditions, and then for a prevailing conditions suitable correction factors or may be applied to represent it or to estimate or to assess the level of service for a given condition, which is the prevailing roadway traffic and control conditions. The standard conditions that are used in HCM so defined are termed as base conditions. Base conditions assume good weather, good pavement conditions, assume that users are familiar with the facility, there are no heavy vehicles in the traffic stream, and there is no impediment to traffic flow. All this, through all this, the base condition or the ideal condition is defined. Let us have a relook at the base conditions for uninterrupted flow facilities. Base or nearly ideal condition: lane width of 3.6 meter, clearance of 1.8 meter between the edge of the travel lane and the nearest obstruction or object at the roadside or in the median, free flow speed of 100 km/h for multi-lane highways, only passenger cars in the traffic stream, that means no heavy vehicles are present in the traffic stream. It is level terrain, there is no passing zones, that means no restrictions for overtaking or passing on 2-lane highways. These are the conditions which are considered for defining base conditions. Also, it is assumed that no impediments to through traffic due to traffic control or turning vehicles. So, if there are left turning or right turning vehicles or other kinds of obstruction for movement of traffic, that will again affect the capacity, or that will again cause deviation from the base condition. So, base conditions assume that there is no impediment to through traffic due to traffic control or turning vehicles. Now, three types of facilities are described in highway capacity manual: basic freeway, multi-lane highway and two-lane highway. We will discuss about all these three types of facilities and how the level of service can be calculated for prevailing roadway traffic and control conditions. First, basic freeway. HCM defines free flow speed as base condition. This is denoted as BFFS, base condition free flow speed, and then also the free flow speed FFS under prevailing condition. So, FFS is the mean speed of passenger cars measured during low or moderate flows. So, it is essentially free flow speed. Now, it is possible that FFS may be measured. If field measurement of FFS is not possible, free flow speed, then this can be estimated indirectly on the basis of physical characteristics of the freeway segment studied. How? Let us look at this thing. Free flow speed equal to free flow speed under base conditions minus reductions due to a number of factors. For freeway segments, the corrections are applied for lane width, adjustment for lane width, adjustment for right shoulder lateral clearance following US convention of driving, adjustment for number of traffic lanes, adjustment for interchange density. So, these are the factors which may affect the free flow speed and which may cause the FFS to be different from BFFS. So, therefore, appropriate corrections are applied. So, adjustment for lane width, adjustment for right shoulder lateral clearance, adjustment for number of lanes and adjustment for interchange densities. Now, how to get these values? Further discussions are given, tables, figures, charts, okay, wherever necessary they are given. So, one can calculate these adjustment factors using those prescribed values and accordingly calculate FFS, what is the free flow speed for prevailing condition. Next is determining flow rate. The hourly flow rate must reflect the influence of heavy vehicles, because in ideal condition or the base condition, it is assumed that there is no commercial vehicles or heavy vehicles. So, hourly flow rate must reflect the influence of heavy vehicle, the temporal variation of traffic over an hour, and also the characteristics of driver population. These are the three aspects which are to be considered to estimate or to determine flow rates. So, influence of heavy vehicle, temporal variation of traffic flow over an hour, and the characteristics of driver population. So, how we consider that? Vp is the 15-minute passenger car equivalent flow rate. This we want to calculate. We know V, that is hourly volume. So, V by peak hour factor. So, this is to account for temporal variation of traffic flow over an hour into n number of traffic lanes, if HV to account for the influence of heavy vehicles, and if P to account for the characteristics of driver population. Again, what should be the value of FHV, FP and peak hour factor, that with the help of HCM we can calculate, where we can get an idea about these values. Peak hour factor basically to represent the variation of traffic flow within an hour. Observations of traffic flow consistently indicate that flow rates found in the peak 15-minute period within an hour are not sustained throughout the entire period, and that is why we need to use peak hour factor. Normally on freeways, peak hour factor values ranges from 0.8 to 0.95. So, if the peak hour factor is known, the same value may be used or suitable values may be adopted in this range 0.8 to 0.95, matching the conditions. Now, this heavy vehicle adjustment factor, what I have indicated here, this FHV component, we are now going to discuss little bit more about this FHV or heavy vehicle adjustment factor. Freeway having mixed traffic volumes must be adjusted to an equivalent flow rate expressed in passenger cars per hour per lane. This adjustment is made using the factor FHV for heavy vehicle, and how we calculate FHV, this equation is used. Now, here ET and ER, two different types of heavy vehicles normally are considered in highway capacity manual. ET is passenger car equivalent for trucks and buses. ER is passenger car equivalent for recreational vehicles. Recreational vehicles are also heavy vehicles, and on certain routes recreational vehicles do operate. So, if there are recreational vehicles, accordingly this ER value is to be taken. Again, what should be the value of ET, what should be the value of ER, further discussions are made in highway capacity manual, and one can pick up suitable values. Now, PT and PR are proportion of trucks and buses. PT is the proportions of trucks and buses, and PR is the proportion of recreational vehicles in the total traffic streams. So, once we know all this, PT and PR are known, ET and ER values may be obtained from HCM manual. We can calculate FHV, the factor which is to be used for heavy vehicle adjustment. Now, determining LOS on the basis of estimated field measured free flow speed. So, we have mentioned how we can calculate FFS. An appropriate speed flow curve of the same shape of the typical curves is constructed. Then, on the basis of the flow rate and speed flow curve, an average speed of passenger car is read on y axis. Let me show that. Let us take this one as an example. So, suppose these are different free flow speed curves, which are not free flow speed, but flow speed volume curves, flow curves which are given. This is a line which is representing free flow speed of 120 kilometer. This is another line which is representing free flow speed of 110 kilometer. This is another operating condition representing free flow speed of 100. This is another which is representing 90, like that. Suppose once we calculate our free flow speed for the prevailing condition, say it is 95. So, what we are trying to indicate that you have this line for 100 kilometer, you have this line for 100 kilometers. In between the red line what I am indicating, that may be considered for representing a free flow of 95 kilometer. So, we know this, we can construct this line or the speed volume relationship. then if we know the flow, say it is 1700 or 1800, then accordingly we can understand what is the speed that can be read. So, first we construct this curve, then for a given volume we calculate what is the speed. Now, the speed is known, the volume is known. So, once the speed is known and the volume is known, we can calculate the density, volume by speed. So, speed we have taken on y axis, we have read it from y axis, I have just discussed that. So, speed is known, Vp is known. How we have calculating Vp, that already I have explained earlier. So, Vp is known, S is known. So, Vp by S is the density. Now, remember that for freeway segment, measure of effectiveness is density. So, that is why we are calculating density end of the day. Now, once the density is known, then for the given condition we can refer to appropriate table and estimate what will be the level of service and what will be the service volume corresponding to that level of service, both the values. Now, further discussions are available, the actual tables are given in terms of exhibit, those are available in highway capacity manual. So, LOS of freeway, basic freeway segment is then determined by comparing the calculated density with the density range given in exhibit. The service volumes also can be estimated. For multi-lane highways, that is about the freeways. Now, coming to multi-lane highways, the approach is similar, whatever we have discussed for freeways. Only thing, values and corrections and the factors are different for multi-lane highways. For example, here also appropriate corrections are necessary to obtain free flow speed under prevailing condition from the free flow speed under base condition or ideal conditions. But here also we apply similar corrections, but look at the corrections, they are different from what we applied for freeway segments. Here we are applying corrections or adjustment for lane width, we are applying adjustment for lateral clearance, we are applying adjustment for median time, and also we are applying adjustment for access points. So, access point adjustment was not there. So, there are adjustment, approach is similar, but actual adjustments which are applied are different. So, again suitable values may be obtained, further discussions are given in highway capacity manual, and you can get what will be the value of FLW, FLC, FM and FA, and accordingly you can calculate FFS for multi-lane highways. For two-lane highways, basically two-lane highways are categorized into two classes for analysis purpose, class 1 and class 2, because two-lane highway is different than multi-lane highways and freeways. Class 1 is highways on which motorists expected or expect to travel at a relatively higher speeds. So, here speed is a major consideration, because motorists are expected to travel at relatively higher speed, that is under class 1. Class 1 includes two-lane highways that are major intercity routes, obviously the speed will be higher, primary arterials connecting major traffic generators, daily commuters routes which are normally used for commuting purpose. So, obviously, speed is a major consideration, or primary links in state or national highway network. These are the roads, type of roads which are normally included under class 1. So, class 1 facilities most often serve long distance trips, they are important, that is why speed is important, or provide connecting links between facilities that serve long distance trips. that is what is class 1 type road. Now, coming to class 2, these are two-lane highways on which motorists do not necessarily expect to travel at high speed. Generally, it serves, or this type of road serves as access route to class 1 facilities. It is not class 1 facilities, it is provides access to class 1 facilities, and motorists do not necessarily expect to travel at high speed. They normally serve as scenic or recreational routes that are not primary arterials. They are scenic routes or recreational route. So, very high speed is not expected, or speed is not the major consideration. So, class 2 facilities most often serve relatively short trips, the beginning and end portion of longer trips, and trips for which sightseeing plays a significant role. So, that way class 1 and class 2 roads are defined. Now, the remaining task is easy. It is now easily understood, or we can get convinced that on class 1 highways efficient mobility is paramount, and LOS therefore is defined in terms of both percent time spent following and average travel speed. So, for class 1 highways LOS is defined based on both percent time following and average travel speed, both are important. On class 2 highways mobility is less critical, and therefore, LO is defined only in terms of percent time spent following without consideration of average travel speed. So, that is the way why the LOS is different, LOS definition is different, measure of effectiveness are different on class 1 and class 2 type 2-lane highways. Question set, some of the questions for you to answer. Define capacity and level of service, describe different traffic factors affecting capacity. Number 3, how free flow speed is estimated from basic free flow speed for multi-lane and 2-lane highways. What are the corrections required for basic freeway multi-lane highways and 2-lane highways? What are the MOEs considered while estimating capacity of 2-lane highway? What are the measure of effectiveness you would consider while estimating capacity of 2-lane highways? Try to answer to these questions. Now, I will try to answer quickly to the questions of lesson 2.4. What are the practical limitations of using radar meters? You know that in some cases you may have to obtain license if the frequencies are within the government regulated frequencies and wavelengths. Accuracy may vary. It is difficult to conceal the radar meter, so drivers tend to slow down. Accurate measurements are obtained only when the radar wave is reflected directly along the axis of the vehicle movement, which is practically difficult. Therefore, adjustment requires a good measurement of angle of wave deflection. Different ways of presentation of spot speed data. One is in the tabular form, where you decide the lower limit and upper limit, and then the middle speed value, observed frequency, and then percentage frequency and cumulative frequency. This is the frequency distribution table. You represent it in terms of frequency distribution curves. You can also represent it using cumulative frequency distribution curve. How are the travel time studies carried out using average car technique? Remember that in average cars, driver is instructed to drive at the approximate average speed of the traffic stream, and this is particularly suitable for multi-lane facilities where it is difficult to follow floating car method. So, there the average cut technique is more appropriate considering the safety and convenience. Now, we record a number of data here, travel time in each direction separately. For each direction of travel, number of overtaking vehicle, number of overtaken vehicle, number of vehicles from opposite directions, all these are recorded. Then appropriately they are adjusted to calculate the average speed or representative stream speed time, and once you calculate this T bar using appropriate corrections, you can calculate V and the Q. Finally, what is total control delay at intersection? Total control delay generally includes time in Q delay plus time losses due to acceleration from and deceleration to ambient speed. Suppose there is no intersection, then the vehicle will go, no signal, the vehicle will go. So, delay is due to the time in Q, the amount of time the vehicle is in Q, that is the delay, one component, and another component is from the normal speed. Once the speed is reduced because of this intersection, there is deceleration. So, from ambient speed to a lower speed following deceleration, and then again may be stopped condition to ambient speed using acceleration. So, it is control delay is time in Q delay plus time losses due to acceleration from and acceleration to ambient speeds. Thank you.